Okay, so I'll just pick up where I left off in the last one. Just quickly go over these. This is just the opposite of this. This is just this, but without being able to equal. Same thing with this. In. So you can just have, so basically in is just if you have two objects that are similar or this one is less, then you can have something in here, A, and you can have it, you can ask if it's in, but you're basically asking, that's not really how it is, but that's just a way of saying it in natural language. In plastic, right? And as we can see, we have this character in here, so this gives you a true. You can just say it out loud. If A in plastic, that's true. N's not very complicated, but is very useful. It allows you, you can kind of do try except with this. So if something is, if you have a thing in a list, for example, then you'll do something with that object in the list. But if it's not, then you don't do that because then that would throw an error because it's not in there. Not just, it just reverses. So if a not in. So this would return a true without the not, but with the not, it reverses it to being a false. And then if we were to remove this, then there was not an A in plastic, so this goes to true because of the not. And allows you to chain multiple statements together. So one and a. So this would be true, but if I change this to be O, then this would be false because both of these statements have to be true for the if statement to pass and for it to result in a true. Or it's just instead of both of them needing to be true, only one of them needs to be true. The only way that or can return a false is if both sides are false. So not too complicated. It's pretty simple. And then what were we on? So we're on 6. Let's go to 7. I don't think this is too important, so I'm just gonna go through real quick. Conditionals. This is just more conditionals. We already went over this. 8. For loops. Yeah, all right, went over this. 10. So yeah, I think yeah, we're kind of done with this. Nested loops. Okay, so nested loops is just when you have two loops. So we only have two types of loops we're using, which is for and while. We're basically not using while loops. We're basically just using for loops. So whenever the main thing we're using for loops for is whenever you want to get into a two-dimensional list. So you have a list scored string list. When you say list, list underscore of underscore list. And then, you have it's inside of a list. You have all these lists inside of a bigger list. And then the way you'd access these, what's inside of this list, so 1, 2, 3, 4, 5, or rather what we want to do. So we have multiple objects in these. So if you want to access these numbers, these integers, what you'd have to do is you'd have to put list of lists in here for list in, well, you can't say list for, you say is lists I don't think is for lists in list underscore of underscore list, and then here you'd say for so this would give you these, and this list right here, that would be the first object that puts in here, and then you say for numbers in lists, and then you'd get 1 and 2. So this would be how you access a two-dimensional list. And if you want to access 3 or so on dimensional list, you just keep adding more for loops. You just keep nesting. So that's what nesting loops is. It's not too complicated. I think it's pretty simple. And that's everything before, and then that's kind of it. But I think we might go over stuff a little bit more in depth on some things, which I think I didn't go over super clearly. Functions, I don't think we need to go over functions. Functions aren't very complicated. Okay, so we can just quickly just go over some more stuff that I don't think I mentioned. So when you're making a function, you're making a function, my idle. Wait, so when you're making a function, there's a few different things you can do. So to make it, you do def, and then you make your function name. So I'll just say adding, right? And then you have this, you have this. Now, what do these bits do? Def is for define. You're defining your function. This is your function name. This is where your arguments go. Even if you don't have any arguments, you still have to have the parentheses. And this is just when you're doing a function, you need to have a colon to tell it that you're going to have you're going to need so you have to tab. If you do this and you start typing here, it'll freak out because it doesn't know what you're doing. So you have to do this, and it tells it that this is inside of this function. And then so you have your code, print hello, and then after, if it's still tabbed, so we have a tab like right here, right? And if we put something here, that will still be in the function, but if we do this, it's no longer in the function, and we can make another function. And then when you end your function, there's a few different things people can do. You can do, I don't remember if doing nothing will work, but pass, I don't remember, I think pass just ends it. I'm not sure exactly. I think it just doesn't do anything. I don't know. But the main thing we're going to do is we're going to do return. And in Java, if you wanted to have a function that then return, I think you did like return void. I don't know how to do this. I guess you could just like return. Actually, I don't know how you'd return nothing. That's a good question. I don't think you're going to usually want to return nothing. Wait, what did I do here? Oh yeah, so if you don't return something, you just don't put a return statement. Yeah. Yeah, but if you do want to return something, this is how you, so if I wanted, adding, so if I want to call adding, I wanted to get some stuff. So let's say I want to add things together, right? I wanted to, so numbers, and I do equals, and I want to do adding, and I want to add 4 and 5. 4, 5, right? I almost just add them there. So we'd have our two arguments. So num1 and num2. So these arguments, what they do is you can insert information into your functions to have them do stuff, basically. This is what's really useful about functions. You can send them any data you want, any data type, a list, a tuple, a dictionary, whatever, and you can have them do anything and everything you want to them, and then you can return it into a variable and have your work done for you. So in this case, we're going to have return num1 plus 2, and what that would do is it would add them together, and you get 9. Now this isn't this isn't a very useful example, but that is something you can do, right? And yeah. It's talking about how functions, these are built-in functions, all this stuff. This is built-in functions, which is very cool, but not super important to know that these are functions. You just need to know they work. They do stuff. Yay. 12. Functions part 2, decomposition. I think I'm pretty sure I know what decomposition is. I'm pretty sure. Let me go look at it just to make sure I'm not missing anything. So decomposition, yeah. So basically what decomposition means is that if you have a really, really long, complicated program, which is doing one really big, complicated thing, what you could do instead is you could break that really big problem into smaller problems. And instead of just having a single main method, instead you could have, so instead of just having this one main method where you have all your code, whatever, and you have 15 lines of code, instead you have your main method, and you could have all these functions that you call, define multiplying, and instead of you having this really big problem, you have a smaller problem, and you have multiple of them, which each smaller problem is a lot easier to solve. So that's what the value of functions, and it's called decomposition, of course. It's more of a concept than a actual programming thing. It's a useful concept in other places as well. I guess you just went over the list again here. Slicing. Don't remember off the top of my head what slicing is. I think I know what this is, but I'm not sure. So let me just check it. Slicing. Oh, right. Yeah, I already went over this. We already went over it here. Yeah, so it's just this. It includes the first number and goes until the end, or if you have this, then it stops somewhere and it's exclusive. And if you only have this, then it starts somewhere over here on this side from right to left, and it goes to the start. Not too complicated. Slicing is pretty simple. I don't think there's anything else I'm interested in. Indexing, mutable, iterating, lesser strings. Operate. I mean, look at operators. So I mentioned in some of my previous ones that if you're having trouble remembering what to do with a different data type, you can just convert it into a list and then just do list things. So let's just look at what we can do with it. So concatenation, yeah, you can add the lists together. Yep, you can do that. Apparently you can't plus equal that. Yeah, you can't add yeah, what this is basically saying is that you can't concatenate something that isn't a list. You can only concatenate a list even if it's only one long. Doesn't matter. Repetition, you can make lists very long by multiplying them, which is not going to be very useful, I think. I don't know, but I can't think of a time you actually use that. Recap. Yeah, so I said dot append, but I guess I just totally forgot concatenation. Yeah, so whenever you want to add something to a list, you can just plus equal whatever you want to add, which is useful. That is useful. It is useful. So if you want to add a variable to a list, what you can do is you have your list here, plus equal, and then in square brackets, you have a variable name right here. So yeah. 14. I'm just going over them one last time. I don't think there's too much to talk about here. Yeah, 2D list. We already talked about this quite a few times. Not much I really want to go. Yeah, I mean it's just a list inside of a list. It's not that complicated. If you want to actually like go over the whole list, you just use a nested for loop like this. It just acts like a list, tuples and sets, and we already went over how those work. So just to recap, you have set, which is like this, and it's not ordered, and it's not iterable. It is iterable. You can go over all of it, but it's not indexable. It's not ordered. It is mutable. You can change stuff. You can convert it into anything else, and it's singular in that you can only have one entity at a time. So I put 1 and 1 in here, but if I were to pull something out, I'd only pull out a singular one, and I could add 1 to it as many times as I want. It wouldn't do anything. It would only be one in there. I need to be ones, made that really hard to say. Tuples are just lists that you can't change. That's it. You can't change them, and there's no difference otherwise. They're not very complicated. I think tuples and sets are very easy. I think the hardest part will be remembering which is which. So we can remember them by saying sets are set in their ways, and tuples are tuples. Yes. I actually got those backwards. Okay. This is, yeah, I'm gonna have trouble remembering this if you can't tell. Geez. Oh, whatever. Yeah. So anyway, yeah. So dictionaries, we remember dictionaries. Set operation. What are set operations? I actually wonder. Wait a minute. So you can't change stuff in them, but you can add and remove from them. Is that what this is saying? Oh wait, no, it's sets. Derp. Derp, derp, derp. That's tuples. I'm thinking tuples. Dictionaries are pretty easy. That's just let me just go back to them. You have your key and you have your key and you have your value, and you know that's kind of the whole. That's kind of it. That's that. They're not that complicated. They're not that interesting. You just have each object is just 2-part. You have key and you have value. Key value pair. Very cool. And you call it by having your dictionary name and then having, what is it? Yeah, and then just having bread. You just name the key and it gives you the value. That's the whole 9 yards. It's not much more. It doesn't get more complicated than that. It's pretty simple. Yeah. I think there are, yeah, and you can delete a key using this function. You can ask if a key is in the dictionary. You can, yeah, I don't know why that's useful, but whatever. You can roll the elements, whatever. Yeah, so it's pretty simple. I think dictionaries aren't going to be too complicated. If you want to add something to dictionary, you just have dict a, and then in square brackets a new key and then equals something, and it'll just have a new value in there. Files, exceptions, and strings. We already talked about exceptions. It's just try except. It's just basically just if else, more or less. String methods, I think it was just split and strip. Too complicated. And then and then we have modules, and we go over exceptions and strings again. What does it do for strings here, I wonder? Oh yeah, there's opening and closing files. You just do file, your variable equals open, and then file name, and then read, writer, append. Not too difficult. And then you just do dot read line, or you put it through a for statement, which is a for loop, which is quite easy. String methods, it's just string slow. Yeah, that's what I thought. Oh, there's join. It's the concatenation of the strings and interval of strings. That doesn't make any sense to me, but I'm sure it would be useful at some point. Ooh, what's this? Oh, here we go. Yeah, so there's we actually I missed to going over these. So dot lower gives you all the letters in a string as lowercase. It converts from lowercase. Upper converts to uppercase. Is alpha. Returns true if they're all alphabetical. False otherwise. Is digit is true if all the strings are numerical. False otherwise. Is space. That's going to be completely useless and no one's ever going to use it, but it returns true if all the characters are white space. There's some constants, you have punctuation, you have digits, you have ASCII lowercase. Neat. And then was there anything else in here we cared about? Modules. Yeah. So the modules, it's just import. It's just import. You just have import and you have the name of the your file, and then you call the function in it or the main method if you want to. And you can use it in a new program, which is very cool. And then finally, we have nested data structures, which are just the same thing as 2D loops, 2D lists. So that's kind of it. I don't think we can get too much more in, and no one has any questions. No one's here for questions. So that'll be all. Good luck on the test.